Hello everyone, I am Prajwal and today we are going to discuss this problem, distinct pairs. This problem is written as easy on CodeChef. So guys, if you haven't read the problem yet, go back and read it, try it out and then come back and see the solution. With this, let's begin. In this problem, we are given two sequences. Sequence A of size n as A1, A2 till A of n. The sequence B is of size m given as B1, B2 till B of m. Now we have to choose k is equal to n plus m minus 1 pairs x and y such that ax plus 1 plus by plus 1 is pairwise distinct. For example, let us say our final pairs are x1 y1, x2 y2 till xk yk. So these summations a x1 plus 1 plus b y1 plus 1 x2 plus 1 and b y2 plus 1. Similarly, till k we will have k sums and all these k sums have to be pairwise distinct. Now it is also given that the elements of A in themselves are pairwise distinct and the elements of B are pairwise distinct as well. We have to output n plus m minus 1 lines where each line is x and y. The constraints given to us are the size of the sequences can be from 1 to 2 into 10 to the power 5. The range of each element can be from minus 10 to the power 9 to 10 to the power 9. And these elements are pairwise distinct among one another. Moving on to the test cases. In the first test case, we are given A as 10 100 and B as 4 3. Now we are given output like these. So if we calculate the sums as A3 plus B2 which is equal to 103, then A1 plus B1 equals 14, A2 plus B1 equals 5 and A1 plus B2 equals 13. So if we convert these pairs into these sums, then we see that all these sums are pairwise distinct. No two sum is common. Hence all these pairs are valid. So in this problem, we have to devise a strategy such that we get n plus m minus 1 pairs. In this case, n is 3, m is 2. So we need 4 pairs, which is 3 plus 2 minus 1. Moving on to the first subtask. In the first subtask, we are given n and m till 1000. So what we can do is we can use a brute force approach. For all elements of A, we will iterate the array B, and if the sum ai plus 1 and bj plus 1 does not belong to map. So this is map basically is a map for storing the sums that we have already encountered. If this is the case, then we just continue. Else, we will add the pair ij into our answer. And if the value of the size of this answer is equal to n plus m minus 1, then we break out. Lastly, we need to add the sum to our map. So the time complexity of this solution is order of n into m. Why? Because we need to look at all the pairs I comma j to get the required solution. The space complexity is order of n plus m. Because we are only storing n plus m minus 1 pairs into our answer variable, and initially we have two arrays of size n and m. This solution will pass the first subtask, however will fail for the second one. Now let us look at the final subtask. For this subtask, you can develop any strategy you want. The strategy discussed here has been used in the editorial. So let us say that we have two sequences A and B. Let's sort these sequences to get A as A1, A2 till A of n, and we get B as B1, B2 till B of m. Now we need to take n plus m minus 1 pairs. So what we can do is we can choose the first value from A1, and we can pair it with all the values from B. So we will get A1 B1, A1 B2 till A1 BM. So this is basically our m pairs. Now for the rest n minus 1 pairs, we will choose the largest value from B, which is B of m, and pair it with all the elements in A except A1. Why? Because we have already chosen this pair in the above mentioned solution in the m pairs. The last element A1 BM is same as pairing BM with A1. So now we will choose A of I and B of M where I is not equal to 1. We will get A2 BM, A3 BM till AN BM. So these are all n minus 1 pairs. So the total number of pairs that we took are n plus m minus 1 as required in the answer. Now let us see why these pairs have different sum. So first of all, the thing to notice is that all AIs and all BIs are pairwise distinct among one another. Hence A1 plus B1 is different from A1 plus B2, which is different from A1 plus B3. Because A1 is common and all BIs are distinct, hence the sum will be distinct. So we have m distinct pairs in this sequence. Now in this another sequence of n minus 1 pairs, we have taken the largest value of B and we are pairing it with all the elements of A. Since we took the largest value and we did not take the first value, the sum A2 plus B1 is distinct from any of the values present in the above sequence. Why? Because A2 is greater than A1 or A1 and BM is greater than all the values except the last one. But since A2 is greater than A1, this sum is actually greater than the last of the previous sequence. So since this is greater than the previous sequence, we are only increasing the value of A, hence we are only increasing the sum little by little. So all these sums will be different from the above sequence. Now this sequence is also different among one another. Why? Because the BM is constant and A is actually pairwise distinct. So we are actually increasing the sum every time we go from left to right. So all these pairs are different, hence the sum is also different. So we get n plus m minus 1 distinct pairs. The complexity of this solution is n log n plus m log n. Why? Because we need to sort these arrays A and B. The space complexity is order of n plus m. Why? Because we need to store arrays A and B and n plus m minus 1 pairs. Now let us look at optimized solution of the above. In the above solution, we take the arrays A and B, sort them, then we take the first element of A and pair it with all the elements of B. And then we will take the largest element of B and pair it with all the elements of A except the first one. So we get n plus m minus 1 pairs. The observation to note is that we only need the minimum value of A, which is the first, and the maximum value of B. And then we can form our pair as min of A comma B of I, which will give us m pairs, and A of I comma max of B, which will give us n minus 1 pairs. Of course, we will not choose the A of I when it is equal to min of A because we have already chosen it in the above pair. Now, the problem of finding minimum and maximum can be done in order of n. Hence, the new time complexity is order of n plus m. The space complexity is still order of n plus m because we need to store the arrays A and B to calculate our answer. Now let us look at the code. First of all, I have processed the input into the variables A and B. These are vectors. Then I use variables min, min index, max and max index to calculate the minimum and the maximum index from arrays A and B respectively. I iterate over the array A and get the minimum index. Then I iterate over the array B to get the maximum index. Now I have used this variable answer of pair intent to store the final answer. Now I iterate over the array B and I push the minimum index, which is from array A, and the index I, which is from B. Similarly, I iterate over from 0 to n, and if I is equal to min index, because we need to avoid the index where the A has the minimum value, else we will append it I comma max index into our answer. Finally, we will output n plus m minus 1 pairs. So guys, this is pretty much the whole code. Try to code it yourself, and if you face any issue, then come back and see it again. So guys, I hope you understood the problem clearly. If you have any questions, drop a comment in the comment section, like the video, and don't forget to subscribe to get our latest updates from CodeChef. Thank you and goodbye.